Imagine a star so dense that a teaspoon of its matter outweighs Mount Everest. Now imagine that star spinning hundreds of times every second, beaming invisible radiation across the cosmos like a cosmic lighthouse. These are millisecond pulsars, and if one ever came close to our solar system, the results would be catastrophic. But beyond the danger, these stellar monsters may hold the key to unlocking the hidden heartbeat of the universe. Chapter 1. Birth of a Monster. Imagine a star that dies in one of the most violent ways possible. A massive star, far larger than our sun, burns through its fuel, collapses under its own weight, and explodes in a supernova. For most people, that's the end of the story. A spectacular cosmic firework. But for astronomers, that's just the beginning. Because in the ashes of that explosion, something even stranger is born. Something so dense and so extreme that the human mind struggles to picture it. This remnant is called a neutron star, and when it spins, we call it a pulsar. At first glance, the name doesn't sound terrifying, but when you begin to peel back the layers of what a pulsar really is, you discover a monster hiding in plain sight. A neutron star is tiny compared to the star that came before it. Most are about 20 kilometers across, roughly the size of a city. Imagine something no bigger than New York City. Now pack inside it a mass greater than that of our sun. That means every spoonful of this material would weigh more than Mount Everest. Its matter pushed to its absolute limit. Protons and electrons crushed together into neutrons, forming a ball of nuclear density. Already, this sounds bizarre, but pulsars take it a step further. When a neutron star rotates, it throws out beams of radiation from its magnetic poles. These beams sweep across the cosmos like lighthouse beams. To an observer on Earth, it looks as if the star is blinking on and off, pulsing with incredible regularity. That's why we call them pulsars. Now, here's where the story turns darker. Some pulsars spin faster than you could ever imagine, hundreds of times every single second. One of them, discovered not long ago, rotates 707 times per second. That's faster than a dentist's drill, faster than a helicopter blade, faster than anything you can compare on Earth. These are called millisecond pulsars, and they are some of the most extreme objects in the entire universe. But how do they get so fast? The answer is as eerie as it is fascinating. Many pulsars have a companion star, often a white dwarf, the burned-out core of a star like our sun. Over time, the pulsar's immense gravity starts pulling material away from its companion. Bit by bit, it steals gas and energy, feeding on it like a vampire. This process doesn't just give the pulsar more mass, it also spins it up, winding it tighter and tighter, until it rotates hundreds of times a second. Astronomers call some of these objects black widow pulsars. Just like the spider that eats its mate, these pulsars consume their companions until nothing is left. It's a slow, quiet act of destruction, unfolding across thousands or millions of years. In the end, all that remains is the pulsar, spinning madly in the dark, having devoured the star that once kept it company. If you stop and think about it, the scale of this is terrifying. Imagine Earth caught in the gravitational grip of such a monster. Our atmosphere would be stripped away by radiation. Oceans would boil. Magnetic storms would rip apart satellites. And if the pulsar came close enough, even our orbit could collapse, tearing Earth apart piece by piece. Luckily, the nearest known pulsars are far away, thousands of light years from us. But the thought alone is enough to unsettle you. What makes pulsars even more fascinating is their precision. Once they settle into their rotation, they keep time better than the most advanced atomic clocks on Earth. Each pulse arrives with astonishing accuracy, tick after tick, like the beat of a cosmic metronome. Some astronomers even call them the clocks of the universe, and this is no exaggeration. But here is the paradox. The universe has created perfect timekeepers. By using some of its most destructive machines, these objects are both beautiful and deadly. They light up the galaxy with their rhythmic signals, but they also remind us of how fragile life really is. Picture it like this. The sun keeps us alive, warm, and safe. It is calm compared to the chaos of a pulsar. Replace the sun with a pulsar, and everything changes. Light as we know it disappears. Radiation floods the solar system. The gravity well deepens. Life, every form of it, vanishes almost instantly. And yet, from a safe distance, pulsars are not just objects of fear. They are also tools of discovery. By studying them, astronomers can learn about matter under extreme pressure, test Einstein's theories of relativity, and even hunt for ripples in spacetime itself. Pulsars, in their silence and fury, whisper secrets about the hidden structure of the universe. In the next chapters, we'll go deeper into that mystery. We'll see how millisecond pulsars act like galactic clocks, how they help us detect gravitational waves, and why they might be the only reason we can hear the faint hum of the universe itself. But for now, hold on to this thought. In the wreckage of a dying star, nature has created a machine of unimaginable power, a monster born from fire and collapse, spinning endlessly in the dark. It is beautiful, it is terrifying, and it is very, very real. Chapter 2. The Deadliest Clocks in the Universe. If I told you the most accurate clocks in existence aren't built by human hands, you might not believe me. After all, we've spent decades perfecting atomic clocks, devices so precise they measured time by tracking the vibrations of atoms. Atomic clocks are used to guide spacecraft, synchronize GPS, and keep the internet running on split-second accuracy. They are, without doubt, technological marvels. But in the vastness of the universe, nature has already created something even better, something stranger, and something far more dangerous. These are millisecond pulsars, stars no larger than a city, spinning hundreds of times per second, sending out beams of radiation like celestial beacons. They are the universe's deadliest clocks, more accurate than anything on Earth. When a pulsar spins, it creates a pulse of radio waves every time its beam sweeps past Earth. These pulses arrive with incredible consistency. If you record the ticks of a millisecond pulsar, they don't just keep time, they keep time better than the finest atomic clocks ever made. Some pulsars have been observed to stay on schedule within a few billionths of a second over years of observation. Imagine a clock that could run for millions of years without missing a beat. That's what these stars are. And here's where it gets eerie. These clocks aren't sitting safely in laboratories. They're not tucked away in climate-controlled rooms at universities. They are violent, collapsed stars, capable of destroying entire solar systems if they wandered too close. So why does the universe give us clocks so perfect, hidden inside stars that could annihilate entire worlds? It's a mystery that scientists are still trying to answer. But one thing is certain. By using these cosmic clocks, we can measure things no human-made instrument could ever detect. Pulsar timing arrays. The Galactic Observatory. Let's imagine you're listening to a dozen clocks, all ticking at once. If one of them stutters even slightly, you'll notice. That's the idea behind what scientists call pulsar timing arrays, or PTAs. Astronomers choose dozens of millisecond pulsars spread across our galaxy. Each one ticks away, sending its steady rhythm to Earth. With giant radio telescopes, scientists listen to these signals, tracking them with extraordinary precision. Now here's the key. If space-time itself stretches or bends, even slightly, those pulsar ticks will arrive a little earlier or a little later than expected. It's as if the universe itself is tugging on the rhythm of the clocks. By comparing multiple pulsars across the sky, scientists can detect patterns, ripples in space-time that wash over the galaxy. These ripples are called gravitational waves. Whispers in the dark. In 2023, an international team of scientists announced something extraordinary. By using pulsar timing arrays, they found hints of a faint background of gravitational waves. Not the sharp signals we've already detected from individual black hole collisions, but something deeper. A steady, low hum that seems to echo across the universe. Think about that for a moment. These millisecond pulsars, spinning endlessly in the darkness, are acting like microphones. They're picking up the whispers of space-time itself. Whispers that we, on our tiny planet, could never hear on our own. The Nanograph project in the United States, along with international partners in Europe, India, and China, have spent over a decade listening to these stars. The data they collect looks like noise at first, but hidden in that noise are tiny shift signals that suggest something massive and unseen is shaping the universe around us. It's haunting to think about. Human ears will never hear these whispers. Our eyes will never see them. Yet through pulsars, we can sense them. What lurks in space-time? So, what could be causing this background hum? The leading theory points to collisions of supermassive black holes. Picture galaxies merging each with a giant black hole at its center. As they spiral closer together, they stir space-time like two whales circling in an ocean. Eventually, they collide, sending out waves that ripple for billions of light-years. Pulsars, scattered across the Milky Way, detect the stretching and squeezing caused by these waves. They are like buoys in a cosmic sea, rising and falling with the invisible tide. But there's another layer of mystery. Some scientists wonder if these signals could reveal things beyond black holes. Could they be hints of exotic cosmic strings, leftover scars from the Big Bang? Could they be signs of hidden dimensions, or the fingerprints of dark matter? We don't know yet, and that's what makes pulsars so eerie. They are not only reminders of stellar death, they are also keys to secrets the universe has buried in space-time itself. The paradox of deadly timekeepers. Think about the irony here. On Earth, we build delicate instruments in labs, shielded from vibration and noise, to measure time. In space, nature builds its own clocks out of fire and destruction. These clocks are not gentle. They are dangerous, lethal. Their beams of radiation could sterilize a planet. Their gravity could tear worlds apart. And yet, they tick with perfection. So perfect that entire scientific fields now rely on them. So perfect that our understanding of the universe is expanding because of them. Every time a pulsar's beam sweeps past us, it's like a cosmic heartbeat. Steady, relentless, unstoppable. And hidden in those beats is information about the deepest mysteries of reality. A foreshadow of what's coming as scientists continue to refine pulsar timing arrays. They expect to uncover more than just a background hum. They might one day identify individual supermassive black hole collisions. They might even chart the history of galaxy mergers across billions of years. But the unknown is even more compelling. What if the patterns don't match black holes at all? What if they point to something no one has imagined? Some force, some structure, lurking unseen in the fabric of space-time. For now, we only have hints. But those hints are growing stronger. And as our telescopes improve, and as more pulsars are added to the timing arrays, the picture will become clearer. So here we are, humanity, listening to the universe with instruments made not of steel and silicon, but of stars themselves. Stars that should terrify us, stars that could kill us. And yet, we trust them to tell us the truth about reality. Millisecond pulsars are, without exaggeration, the deadliest clocks in existence. They are monsters that keep perfect time, and as long as we listen to them, they will continue to reveal the universe's most guarded secrets. The question is, what will we hear next? Chapter 3, Gravitational Whispers. Imagine dropping a stone into a still pond. Waves ripple outward, spreading farther and farther until they reach the shore. Now replace that pond with the entire universe, and replace the stone with something unimaginably massive, like two black holes colliding. Those ripples still exist, but they don't move through water, they move through space-time itself. Einstein predicted them more than a century ago. He called them gravitational waves, distortions in the fabric of reality, traveling at the speed of light. At first, the idea sounded impossible to test. After all, how can you measure a ripple in space-time itself? But in 2015, scientists proved him right. The LIGO experiment in the United States detected gravitational waves from two black holes smashing together over 1 billion light-years away. It was one of the greatest scientific discoveries of our time. But here's where the story gets darker, more mysterious. The waves LIGO detected were high-pitched and short-lived, like the quick splash of a stone dropped into water. But what about the deep, slow waves, the ones that roll across the universe like an ocean tide? These are the ultra-low frequency gravitational waves, and no human-made detector can hear them. They're too vast, too stretched out in time. So, how do we detect them? The answer lies in the deadliest clocks we met earlier, millisecond pulsars. Pulsars, as cosmic sensors, picture a row of metronomes ticking on a table. Each one keeps a perfect beat. Now imagine someone bumps the table. The ticks all shift at the same time, just slightly. That's what happens when a gravitational wave passes between Earth and a pulsar. The pulses arrive a little early, or a little late, shifted by the stretching and squeezing of space-time. By listening to dozens of pulsars scattered across the galaxy, astronomers can compare their rhythms. If they all shift in a coordinated way, it's not random noise. It's a gravitational wave sweeping across the Milky Way. These pulsar timing arrays are like a galaxy-sized observatory. Instead of building one massive detector on Earth, scientists are using the universe itself as the instrument. Each pulsar is a ticking sensor, spread out over thousands of light-years, waiting to catch the faint tremors of reality itself. And recently, those tremors have started to appear. The cosmic hum. In 2023, international collaborations including Nanograph in North America, the European Pulsar Timing Array, and groups in India, Australia, and China announced tantalizing results. After decades of patient listening, they detected signs of a low-frequency gravitational wave background. Think of it like this. LIGO hears the crashes of individual cymbals in a cosmic orchestra. Pulsar timing arrays hear the deep, continuous hum of the entire concert hall. The data suggests that across the universe, pairs of supermassive black holes, millions or billions of times the mass of the Sun, are spiraling toward each other. After their host galaxies merge, each pair stirs space-time, sending out slow, rolling waves. All of these signals overlap, creating a cosmic background. And here's the haunting part. We are living inside that hum. It's everywhere, all around us, all the time. We don't feel it, we don't hear it, but the pulsars do. It's as if the universe itself is humming a funeral song, and millisecond pulsars are the only ones who can hear it. The funeral song of black holes, to grasp the scale. Consider this. When galaxies collide, their central black holes dance together for millions of years before merging. Each step of that dance bends space-time. Each orbit shakes the very structure of reality. The waves they produce are enormous, spanning light-years from crest to crest. Too slow for LIGO to catch, but perfect for pulsars to record. Astronomers analyzing the data see patterns that fit this story. The hum could very well be the combined chorus of countless black hole pairs across the universe, each singing their verse in a song of destruction and rebirth. It's haunting, but also beautiful. A galaxy dies, a new one is born, and the echo of that cosmic violence ripples outward for eternity. Beyond black holes, the mystery deepens. But as always, the universe refuses to give us only one answer. Some scientists suggest that the gravitational wave background might not be only from black holes. There could be other explanations, stranger ones. Some theories point to cosmic strings, hypothetical cracks in space-time left over from the Big Bang. If they exist, they could snap and vibrate, releasing gravitational waves across the cosmos. Pulsars could be the only way to detect them. Others wonder if these signals might hint at something even more exotic, hidden dimensions curled up beyond our perception, leaking their presence into space-time through these faint tremors. Right now, no one knows. That's the mystery. The data are strong, but the interpretation is still open, and every possibility is unsettling. Either the universe is filled with colliding giants, tearing at space-time, or it hides structures we've never dreamed of. The fragile fabric of reality. There's something unnerving about this picture. We like to think of reality as stable, solid, unchanging. But gravitational waves remind us that the universe is flexible. The fabric of space-time itself can stretch, bend, and ripple like the surface of a drum. And we're not outside that drum. We're on it. Every ripple passes through us, through our planet, through our bodies. We don't feel it, because the effect is so tiny, but pulsars feel it. They mark the shifts in their relentless ticks, like perfect stenographers, writing down every shiver of space-time. It means the ground beneath existence is not fixed. It's alive, vibrating with ancient echoes of violence we can barely comprehend. A whisper that could change everything for now. The whispers are faint. They don't tell us exactly where the waves come from or what they mean. But the more pulsars scientists add to their arrays, the clearer the whispers will become. In the future, we might be able to trace the signals back to individual pairs of black holes, catching them in the act of merging. Or we might hear something else entirely, something that doesn't fit any prediction. The thought is thrilling, but it's also chilling. Because if these whispers reveal hidden structures or dimensions, it could mean that the universe is stranger, darker, and more unstable than we ever dared to imagine. So next time you look at the night sky, remember, it's not silent. The universe is humming. A constant, ghostly vibration. The sound of galaxies colliding, black holes merging, maybe even stranger things stirring in the dark. We can't hear it, we can't feel it, but the pulsars do. They're deadly. Perfect ticks carry the record of a cosmic song older than life itself. And the more we listen, the clearer that song becomes. It's a funeral song. It's a love song. It's a warning. And it may be the key to unlocking the deepest secrets of reality. Chapter 4. When the clock strikes. Doom. Close your eyes for a moment, and imagine the solar system as a quiet clockwork machine. The planets circle the sun in smooth orbits. Earth spins, protected by its atmosphere and magnetic field. Life continues in a fragile balance. Now picture something tearing into that balance. A visitor from the deep night of the galaxy. Not a comet, not a rogue planet, but something far stranger and infinitely more dangerous. A millisecond pulsar. This is not just a star. It is a collapsed heart of a once massive sun, compressed into a sphere no bigger than a city. Its density defies imagination. A spoonful would outweigh mountains. It spins hundreds of times per second, sweeping out beams of deadly radiation like the blades of a cosmic lighthouse. And now imagine that monster drifting into our solar system. What happens next? The sky burns first. The beams. A pulsar's radiation is not gentle. It is a flood of X-rays and gamma rays strong enough to strip atmospheres bare. If one of those beams passed across Earth, the effect would be immediate and catastrophic. The upper layers of our atmosphere, the shield that protects us from solar radiation, would be obliterated in moments. Ultraviolet light from our own sun, normally blocked, would pour through unchecked. The skies would ignite with auroras, but they would not be beautiful. They would be death signs, as oxygen and ozone molecules tore apart. The oceans would begin to evaporate. Plants would wither. Animals would collapse under the radiation. Within weeks, Earth would look less like a blue world and more like Mars, dry, cracked, lifeless. And that's only the beginning. Gravity in chaos. Pulsars may be small, but their gravity is immense. Imagine compressing the sun into something only a few miles wide, that's the density we're talking about. If such an object passed anywhere near our solar system, the gravitational balance would shatter. Planets would be tugged from their orbits. Some might spiral inward, others might be flung into the dark void. Moons would drift loose. Asteroids in the belt would be hurled like bullets across interplanetary space. The stable dance of the solar system, something that has lasted for billions of years, would dissolve into chaos in a matter of centuries, maybe even decades, and Earth, if not roasted by radiation, it could be pulled from its orbit entirely, cast adrift into the cold between stars. The collapse of Earth's shield. But there's something even more terrifying. Earth's magnetic field. Our planet has a natural defense against cosmic radiation, a magnetic bubble generated by the churning of molten iron in its core. It deflects charged particles from the sun, shaping the auroras at the poles. Without it, life would never have survived here. Now imagine that shield facing the direct beam of the pulsar's radiation would overload Earth's magnetic field. Instead of graceful auroras, the skies would be filled with storms of particles. The magnetic field would twist, distort, and finally collapse. Earth would be naked in space, its surface scoured by deadly radiation every moment. The thin traces of life still clinging on would vanish. It would not take centuries. It would not take decades. In the presence of a pulsar, the end could come in years. The cinematic horror picture, the scene from the ground. At first, astronomers would notice something strange. A new star in the sky, pulsing with clock-like precision. Every fraction of a second a flash. Some would dismiss it as harmless. Others would sound the alarm. Then the radiation would arrive. Satellites would fail. Power grids would burn out. The night sky would flicker with storms of light. Animals would flee in confusion, their instincts shattered by invisible waves of energy. Within months, crops would fail. The oceans would steam. Humanity would fight for survival in underground shelters, but even those would not last. The pulsar would not rage, it would not roar. It would simply tick, merciless and perfect, counting down to the final moment when Earth's story ends. Safe. For now, here's the unsettling truth. We are safe. For now, there is no pulsar close enough to threaten Earth today. The nearest ones are hundreds of light years away, far beyond the reach of their beams. But the Milky Way is filled with them. Thousands are scattered across the galaxy, hidden in the dark like cosmic predators. Most mind their own business, spinning in silence. But some are more dangerous Black Widow pulsars. These are pulsars that feed on their companions. Like cosmic vampires, they siphon matter from nearby stars, stripping them down until nothing remains but a cinder. Their beams sweep across space as they consume their partners, leaving behind only silence. It is not hard to imagine what would happen if such a predator drifted too close to us. Doomsday engines, a pulsar in our solar system, would be more than a hazard. It would be a doomsday engine. Its radiation could sterilize planets. Its gravity could shred orbits. Its magnetic fury could erase the conditions for life in an instant. And yet, in their destruction, pulsars are also beacons. They guide us, teaching us about the universe, helping us measure time and space with unmatched precision. This is the paradox. The same stars that could end civilizations are the ones we rely on to understand the cosmos. They are destroyers and teachers, executioners and prophets. So what do we do with this knowledge? We remember that the universe is not safe. It is not calm. It is filled with forces beyond our control. Pulsars are one of those forces, reminders that reality itself is fragile, that existence hangs on a balance that could be tipped at any moment. We are safe today, yes, but safety is only temporary. The galaxy is vast, and time is long. Somewhere out there, more pulsars spin, waiting, tick, 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 and each tick is a warning, because when the clock strikes doom, there is no escape. Chapter 5, The Double-Edged Gift. If you've stayed with me this far, you already know the truth. Pulsars are not ordinary stars. They are paradoxes wrapped in radiation. They are both guides and threats. They give us answers, and at the same time, they whisper warnings. And that's what makes them the double-edged gift of the universe. Hope, tools of the cosmos. On one hand, pulsars are extraordinary tools. Imagine you are a sailor, lost at sea. In ancient times, sailors used the stars to navigate. Pulsars could be the next step, celestial lighthouses for travelers between the stars. NASA has already tested this idea. A project called Sextant placed a navigation system on the International Space Station. Instead of GPS satellites, it used pulsar signals. By listening to the ticks of millisecond pulsars, the system could locate itself in space with astonishing accuracy. The test worked. This means that, one day, spacecraft exploring deep space may chart their course using pulsars as cosmic signposts. That alone would make pulsars valuable. But they give us more, much more. They let us measure the universe itself, the hum of the universe. Through pulsar timing arrays, scientists detect the stretching of space-time ripples from massive black holes colliding. Without pulsars, those signals would be hidden forever. Think of it this way. Pulsars are scattered across the galaxy, like microphones placed in a grand concert hall. The concert is space-time itself, and the music is faint, deep, and slow. Too low for our ears, too long for our instruments. But pulsars pick it up, and through them, we can hear the universe humming. This is not just theory. We've already found evidence of a gravitational wave, background a cosmic symphony echoing across billions of years. Without pulsars, that discovery would never have happened. They are showing us the hidden structure of reality, piece by piece. Guardians of secrets, pulsars may even tell us about things we cannot yet imagine. Some scientists believe they could reveal evidence of cosmic strings, hypothetical cracks in space-time left over from the Big Bang. Others think pulsar signals might one day uncover new dimensions or exotic forms of matter. It's as if pulsars are guarding secrets, waiting for us to learn how to read them. Each tick, each pulse, is a message written in the language of physics. We are only beginning to translate. In this way, pulsars are like libraries. They store information about gravity, matter, and time itself. But unlike a library on Earth, these shelves are dangerous. To approach too close would mean death. We can only read their books from a safe distance. Fear, the violence behind the gift. But here is the other side of the blade. Pulsars exist only because stars die. They are born from explosions so violent that they can outshine entire galaxies. When a massive star collapses, it crushes its heart into something dense beyond comprehension. That collapse is what creates a pulsar, and what keeps them spinning. Sometimes, it is the slow consumption of a companion star. Black Widow pulsars devoured their partners, tearing matter from their surfaces until nothing remains. So when we look at pulsars, we must remember, their very existence is a scar, proof of cosmic violence. And their beams, those perfect clocks, are not gentle signals. They are blasts of radiation that could sterilize planets. They are reminders that life, fragile as it is, survives only because these monsters remain far away. The fragility of life, every discovery of a new pulsar is thrilling, but every discovery also reminds us how delicate our place in the universe really is. Earth orbits peacefully around the sun, shielded by a magnetic field, warmed by a gentle star. But out there, in the dark, are thousands of pulsars. Each one is a potential doomsday engine. Each one could strip a planet bare, tear apart its atmosphere, and erase life in a heartbeat. It's easy to feel small when we realize this. Easy to feel vulnerable. But perhaps that's the point. The universe does not exist to comfort us. It exists to remind us that survival is rare, that life is precious. Pulsars are symbols of that truth. The philosophical close. So where does that leave us? On one hand, pulsars are executioners. They are the byproducts of death, reminders of destruction, cosmic blades that could slice through life without hesitation. On the other hand, pulsars are librarians. They are keepers of knowledge, guardians of secrets about time, gravity, and the structure of reality itself. They are the very tools that allow us to glimpse the hidden order of the universe. Millisecond pulsars are both executioners and librarians, beings that kill, yet also teach. They embody the strange paradox of the cosmos. Violence giving rise to knowledge, death giving rise to discovery. When we study them, we are not just learning about stars. We are learning about ourselves, about how fragile we are, about how rare survival is, about how, in the face of destruction, knowledge can still emerge. Perhaps that is the lesson of pulsars. They may be the universe's deadliest clocks, but they may also be the only reason we can tell time on a cosmic scale. If this glimpse into the deadly beauty of millisecond pulsars left you with more questions than answers, you're not alone. Leave a comment with the mystery you'd like us to explore next. And if you want to keep traveling deeper into the unknown, don't forget to like this video and subscribe for more cosmic mysteries.